Hi, everyone. In this video on section 4.3, we're going to talk about conservation of energy. So we need to know what conservation of energy is, and we also need to know what a closed system is. So the law of conservation of energy states that in a closed system, the amount of energy within the system remains fixed. Energy can be converted from one type to another, but the aggregate amount remains the same. So there's a lot of words in there that we should define, starting with a closed system. What does it mean for a system to be closed? Now, I've already written in the definition of closed system just to kind of save some time and not force you guys to watch me write it. But a closed system is a portion of the universe chosen for analysis, which does not exchange any matter with its surroundings, nor does it experience a net force. And actually, a closed system is something that you guys have already dealt with in this class. We dealt with closed systems when we thought about Newton's first law, because a closed system, or actually, I should say, when we drew force diagrams, and I'm going to do a very boring example. I'm just going to talk about a box. But when we did force diagrams, the very first thing we drew on our force diagram was a dotted line to signify our system so that we can say, this is the thing I'm interested in looking at, right? This is the portion of the universe that I have chosen for analysis, okay? And so we did that all the time when we drew force diagrams. We said, I'm gonna pay attention to this, I'm gonna ignore all of these other things. Now, a closed system just has some additional language associated with it. We cannot exchange any matter with the surroundings, so the mass needs to stay the same in a closed system. And then the second thing is that we cannot have any kind of net external force. And again, this is a situation that you guys are pretty familiar with because of Newton's first law. Newton's first law was entirely made up of systems where there was no external net force applied. Okay, so all we're doing is we're just assigning a name to something that we've seen before. Other words that we should probably talk about when it comes to the law of conservation of energy is this word aggregate. So what does that word mean? What does it mean that energy can be converted from one type to another, but that the aggregate amount remains the same? Aggregate is just a synonym for total. So you could almost rewrite this sentence as energy can be converted from one type to another, but the total amount remains the same. So what that's saying is that if we have some kind of phenomenon occur, or maybe some kind of motion, anything like that, if we can count up how many joules of energy are within our system at the beginning, and then we can count up how many joules of energy are in our system at the end, those two numbers need to be the same, okay? So the total amount of energy at the beginning has to equal the total amount of energy at the end. We cannot spontaneously create joules of energy in our system. We also cannot spontaneously lose joules of energy in our system, okay? That's really what the law of conservation of energy is trying to get at. Now, because we tend to want to express things mathematically in this class, the way that we could express the law of conservation of energy mathematically would be to just explicitly write a math equation that totals together all of our energies at the beginning of a phenomenon and at the end of the phenomenon and set them equal to each other. So what would that look like? Well, we would maybe want to look at our kinetic energy at the beginning, and we would want to look at our gravitational energy at the beginning. We'd want to look at spring energy at the beginning, and we would want to look at thermal energy at the beginning. And our total energy is going to be the sum of those four types of energy. And the law of conservation of energy says that that sum has to be equal to the sum of kinetic energy at the end, plus gravitational energy at the end, plus spring energy at the end, plus thermal energy at the end, okay? So this is more of a mathematical way of stating that same law of conservation of energy.